So really good afternoon and welcome to ScholarSip. I'm Danuta Yatetsky, Dean of Libraries, and I'm really pleased to welcome you to today's virtual ScholarSip event. So we are recording this session, and as with our other events, we will post the recording on the library's YouTube channel. And I think Stacy will probably give you a note in chat how to connect with that. We'll have time at the end for questions and comments, and please stay muted throughout the presentation otherwise. So as you know, or as many of you know by now, this year marks the 10th anniversary of ScholarSip. We created this cement series back in March of 2012 as part of our work to help build a cross-campus intellectual community at Drexel and to share a toast to the end of the academic term. So we're excited to continue that tradition today. So this year, to celebrate 10 years, instead of hosting our normal 3 events once a quarter, we decided to host 10 food for thought sessions running through the end of the spring term. And this is where I take a little pause to thank Stacy Stanislav, who's our communications and events manager, for this brilliant idea. And then halfway through, she said, I don't know if we're going to continue this next year, but if you think it was a good idea, maybe we can get encouragement to see if we can continue it the same kind of post. But anyway, thanks. She is the one that makes this happen with attending to all the details to get this thing kicked off. So it's hard to believe, but today marks our 8th event since December of 2021. That means we have 2 more to go. One will be on June 1st, which will feature the CCI Assistant Professor Shaheen Jabari, and our final spring term event featuring law professor Paul Flanagan on June 6th. That final event will be held in person at the Study Hotel, just next door to the libraries here, and we will offer a virtual option as well for those off campus. And so we really do hope to see all of you to come back in person for this grand finale for this year's series. And now I'm pleased to give a brief introduction to today's ScholarSip speaker. Hasan Ayaz is an associate professor in the School of Biomedical Engineering, Science, and Health Systems with a joint appointment in the Department of Psychology, as well as affiliations at the University of Penn and the Children's Hospital of Philadelphia. Professor Ayaz is also a core member of the Drexel Concur Collaborative, an acronym that stands for the Cognitive, Neuroengineering, and Quantitative Experimental Research Collaborative. Having earned his Bachelor of Science in Electrical and Electronics Engineering at the University of Boğaziçi, do I have that close, in Istanbul, Turkey. He received his master's and PhD degrees from Drexel, so go Dragons, where he has developed enabling software for functional near-infrared spectroscopy-based brain monitoring. You've got a mouthful here. And FDA-approved medical devices. His research interests include neuroergonomics and neuroengineering in human-computer interaction, as well as applications of optical brain imaging. So Professor Ayaz's research involves understanding the neural mechanisms related to human, perceptual, cognitive, and motor functioning with a focus on real-world context. His research aims to design, develop, and utilize next-generation brain imaging for neuroergonomic applications over a broad spectrum, including aerospace to healthcare. Professor Ayaz also serves on the editorial board of multiple international journals, including PLOS One and Computational Intelligence in Neuroscience. He is also a frequent reviewer of over 50 other journals and has served as the co-chair of the inaugural and second International Neuroergonomics Conferences. The recent celebration, our own here, of the authors' events, hosted by the provost and the libraries, recognized Professor Ayaz for his 2021 journal article that was included in Clarivate Analytics' annual list of highly cited papers, a truly prestigious ranking that recognizes journal articles that were both published and highly cited in the same year, putting them in the top 1% of their academic fields. So before I turn the Zoom controls over to Professor Ayaz, let's continue our ScholarSip tradition of raising a virtual toast. And as it's, I think now, the 10th week or so of the term, let's do it to getting through here. Those of us that are on the quarter system get through this spring term, all with our sanities. Here, here. So thank you again for joining us today, Hasan. Controls are over to you.
Great. Thank you so much. Good afternoon, everyone. And I would like to thank the Dean of Libraries, Danuta Tejki, for this kind introduction and the opportunity to be here with you to share my experiences, my research. So let me start sharing my screen. Okay. Can you see some slides? Okay, great. So today I will talk about a little bit about my research and with a focus on this new field that we have been growing with a large community from around the world. And I will talk about how we started these efforts and how we have been serving this community. Okay, so again, to give some feedback, I will mention a little bit about my research, this growing area that we call neuroergonomics. I will introduce the field, what it means, and what is the scope, and then how we have been working on building this community. That started with maybe events like workshops, webinars, symposiums, and at different conferences, like more established traditional events. Then with more time and more kind of growth of involvement of the community, it turned into a new international conference series that we have started. And then a comprehensive book about the methodology and applications. Then we have seen this emerging need for actually an academic home for this new domain. And we started a new journal with a large body of colleagues that is Frontiers in Neuroergonomics. And I will tell you a little more about that. Okay, first, my research focus. So my research is on understanding human brain function in everyday life. So this is basically using wearable and mobile neuroimaging to capture brain activity in complex, ecologically valid, everyday tasks in unrestricted scenarios. So this is a big step, in a new direction from traditional neuroimaging that is typically done in labs, in artificial tasks and with restricted settings. So we're trying to break that limit to understand more about the brain using new generation of tools that we have developed or others have developed to better understand the human brain. And we do that by first measuring the brain, looking at new biomarkers, new patterns and signals, developing new methodologies to accomplish that. And also we work with domain experts from diverse areas to adapt these approaches, these neurotechnologies to solve domain-specific problems from clinical to field settings. Okay, so I will tell you more about neuroergonomics, but just to highlight that this is really at the intersection of neuroscience, neuroengineering, with a large body of other disciplines to drive expertise and know-how from them to serve real-world challenges. And this became really a growing kind of body of research area. And we have been working on a lot of dissemination of ideas, but at specific conferences, different areas like human factors, engineering, or neuroscience conferences, we have been discussing, okay, this is the new area, and we have developing sessions in these conferences, then developing tracks that are focused on neuroergonomics. Eventually, then it was around 2015 that with my good friend and colleague, Professor Frédéric Dehaye in Toulouse, France, we come together and said, we have to have a dedicated conference for this new field. And we had so much interest that we were so excited, and we decided to set it up in 2016 October in Paris, France. And AXA, actually, interesting enough, an insurance company made a huge kind of funding available to enable this. And later on, we received also a lot of sponsors, a lot of interest from the community to kickstart really this very exciting journey. And as the research grew, we see this increased actually interest, and later resulted in additional conferences. The second conference was actually here in Drexel in 2018. We had a wonderful event with attendance from 17 different countries, over 300 researchers dedicated to understanding the human brain. And the following conference actually was supposed to be in Munich, Germany, the third International Neuroergonomics Conference, but because of the COVID, unfortunately, we had to turn into an online conference. And it was actually this past September, and we actually had a lot of success in this virtual conference where we met over and through this Gather Town event management tool that enables people to have some sort of avatar and still join presentations and some spontaneous communication through this virtual communication channel. And with all that, now we're getting ready for our next conference, which will be in New York City at the end of July. And this will be together with the New York City Neuromodulation Conference, and Professor Maron Dixon at City College, New York, is hosting us. So this is kind of a growing trend of events. We have a lot of presentations, a lot of researchers coming into this field, but also a lot of tutorials. We had a lot of training opportunities for the young generation of researchers in these events. And that's something like this. Workshops and trainings have been a core area that we were training these fundamental concepts and tools that enables diverse research from neuroimaging to neurostimulation, the brain-body imaging in general at these events. And this has been serving well for the young generation, like graduate students that are starting their programs and deciding on their thesis. They capture these necessary skills so that they can actually develop a more impactful research plan. So this has been serving well. And one aspect that came up in all these conferences, even starting with the first conference that Frédéric and myself chaired, was that they wanted a dedicated home, an academic home for the scholarly publications of these activities. Because we have all these fantastic journals in the field, in neuroscience, in engineering, yes, but they all lacked some important aspect of the background that really makes neuroergonomics unique. So that stimulated, after, especially with the second conference here, that was emphasized with the community, with the growing community, that we had in this conference, not only university researchers, but a lot of industry researchers and government research organizations. They involved. We had funding from diverse companies. We also had funding from Air Force Research Lab. So it was, clear that there is a niche and there is a need for this kind of research that is serving both development of theories and also applied and translational research opportunities in this area. So then we come together with another colleague, Professor Waldemar Karwowski, actually from University of Central Florida, Orlando. And he has actually been a prolific editor. He has huge number of books that I've been reading when I was even a student. And he's very active in terms of editorship in journals, previous chief editorship. And we came together and we said we have to put the time necessary to really put together a successful proposal that we established this new journal. So we put together that proposal after a lot of effort and a lot of feedback from our colleagues from all over the world, US, Europe, and other places. And we started discussions with different publishers. And finally, Frontiers really made a lot of sense for us because we already have done a lot of research topics with Frontiers, and just actually we finished after the second International Neuroergonomics Conference. We completed a special issue that Frontiers calls research topics, and we had actually a huge number of submissions that more than what they typically see. More than 50 journal papers published eventually, and Frontiers were also very excited about this. We put together the plans, and we started this new journal with first a publication from the three of us, Waldemar, Fred, and myself, to define this field. So this is now available as the first publication in the journal that defines the scope and what we understand and perceive as this new emerging field. And our now actually we started inviting our research colleagues, and we now have over 400 experts from all over the world in the editorial board of this new journal, and it's growing. And this is slide is from a while back. Now it's over 400 even, and I think it will grow much larger because there is a lot of niche and there is a lot of opportunity for exploring different neuroergonomic applications. So I think there is something that everyone can contribute from all these diverse disciplines, and that makes it exciting. All right, so our goal with the journal is to put together a venue that actually enables highest quality original research publications. That can be for methods, applications, it can be modeling, simulations, all related to brain function in realistic or real world settings. How can we expand the body of know-how about the brain, stepping out of the lab, stepping out of the restricted settings? How can we learn more about the brain function? And our main aim is to make this journal a home for all neuroergonomists, and a main publication and dissemination of new research and ideas and concepts. And what's exciting is that we have actually 7 different sections. Each are organized actually as another journal. So in effect, we have a collection of 7 journals. So each of these sections have specialty chief editors and an editorial body within them. And we have excellent group of colleagues actually for example, in augmented and synthetic neuroergonomics, Maron Dixon, Daniel Callan. We have cognitive neuroergonomics, Klaus Grahmann, consumer neuroergonomics. We have Anne-Marie Brower in neurotechnology and systems neuroergonomics, Stefan Feriklau, and we have physical neuroergonomics, Stefan Perret, and social neuroergonomics, Frank Kruger, clinical neuroergonomics, Daniel Lev, and with systems neuroergonomics, we have Fabian Lott. So they're excellent researchers that have made significant contributions to their fields, to this emergence of this field as well. And we have a lot of kind of other colleagues that are serving as associate editors that I can't even begin to list in this limited time. And just to mention, we have colleagues from all over the world in the editorial board. We have like a lot of folks are from United States, but also France and Germany and Brazil are other areas. We have a lot of editors in the board, and we are aiming to be diverse and all-inclusive so that we can represent this new emerging field and be a home for all that wishes to do neuroergonomics research. So this is basically, I just wanted to highlight this efforts, but maybe let me see if there are any questions, because I want this to be more informal and interactive, and would like to see if there are any questions or comments so far.
And so let me just interject. Thanks very much, Hasan. That sorry, you're going to hear background noise here. So feel free either to raise your hand, or since we're a small enough group, if you simply unmute and share your reflections. If you prefer, you can also type your comments or question in chat, and Stacy will read them aloud so others have it. And please identify again who you are and what field you're from, because I think this is really the theme of this particular presentation is about dissemination and creation of a new discipline in a very interdisciplinary landscape. So
maybe while people are thinking about what to ask, I can continue a little bit about some aspects, some definitions.
Well, then finish your food or thought, because that's where we want to leave the time for the whole piece.
So yeah, I can give a little more perspective about why we need this area and how it is different than existing disciplines. So let's, before we start though, let's talk about some key concepts. So this is about human brain, and this miraculous 3-pound spongy tissue is really the most complex machine in the known universe. It contains around 80 billion neurons, trillions of neural connections between them that is constantly reconfiguring itself. And each brain has the same fundamental architecture, but also unique characteristics like our faces, right? And these unique features are cumulative effects of our lifelong experiences and our environment that shapes us. So each of you actually are unique, very special, and everything you do, each decision you make, things you learn have an impact on the brain. So here you're seeing a beautiful micro-etching artwork called Self-Reflected from neuroscientist and artist Dr. Greg Dunn, and artist and applied physicist Dr. Brian Edwards. Self-Reflected is actually on permanent display at the Franklin Institute, a world-class science museum here in Philadelphia. So I'm sure most of you have visited. If you haven't yet, it's highly recommended. And Dr. Dan explains this self-reflected aim is to elucidate the nature of human consciousness, bridging the connection between this mysterious 3-pound tissue and the macroscopic brain and the behavior of neurons. And there is a lot of detail and a significant portion of basic research in neuroscience actually focus on that, from genetics to molecular. But today, we will focus on the macroscopic scale with neuroergonomics. We're looking at the brain and even multiple brains and their interaction with each other and the complex environment or the tools and machines. So we are focusing on functional brain activity. That actually means the spectrotemporal changes in the brain as it works. And this is different than structural brain imaging. So structural brain imaging captures the anatomical layout of the tissue. So with functional neuroimaging, we're looking at the activity. So to give you an idea, like for those out of the field, structural brain imaging is like mapping the highways, roads, or streets, versus functional brain imaging maps the traffic over time during specific events. So we're looking at the activity. And also, our focus is on everyday life. And what does it mean? So typical brain research is actually done, as I mentioned, in artificial limited lab settings, highly controlled, but also very restrictive. So participants may not move. They cannot do anything other than the very specific tasks that are highlighted. And that's for a reason. We want to look at very specific contrast. But this means the type of brain activity that we can measure is only a small portion of what is out there that happens in the real world. So we want to actually break those barriers to really study the brain in all these diverse and complex settings. And that's reaching the everyday life. And this can be anything, like doing specialized tasks like workers, warfighters, operators, pilots, surgeons, or students performing critical tasks, but also relaxing, collaborating, playing. In short, everything and anything that we do can be studied. But this is a big change from typical brain imaging settings. But if successful, this can provide incredible information about the brain, how to improve us, creating a better us, improving our performance and the tools that we use. And also, it has a lot of clinical dimension, enabling new ways to diagnose, treat, and even prognose any neurological or psychiatric disorders. So there are a lot of opportunities for research. And neuroergonomics is at this intersection of these diverse disciplines. So with neuroergonomics, we're trying to understand how to apply all these new emerging tools and approaches to better understand human brain function. And just to give you a little more context, with functional neuroimaging, the aim is to first identify the relationships and the changes and relate that to behavior, and then maybe use this to develop an intervention. And with typical neuroimaging, like traditional tools, we can map the structural brain networks, yes, and we can look at the resting state or limited tasks state brain activity. But when we consider this extent of diverse tasks that we do, the evoked task-related brain changes are very limited, in terms of what we can do with traditional neuroimaging. So we really need mobile brain imaging tools to new approaches to really understand the link and this make the connection. And neuroergonomics is here to help us actually, and that's the gap that the neuroergonomics is filling. And this is a huge trend that we're seeing in the whole kind of field that goes back to the design of tools like in human factors, human performance, cognitive engineering, and neuroscience. And it originates from the scientific thinking of design of tools to working environments. And neuroergonomics actually represents the next frontier for brain-in-the-loop systems. And again, maybe to give some perspective, we can look back, the emergence of computers, for example, and which actually happened very near us, very close in Philadelphia. This is the first digital computer, ENIAC, the electronic numerical integrator and computer, was developed at the University of Pennsylvania. And at the time, it was a big revolutionary development. And it was announced by New York Times at the time as the amazing machine that applies electronic speeds to mathematical tasks. And it is a room-sized device. The machine shown here with the technicians actually took up an entire room, and it weighed 30 tons and used more than 18,000 vacuum tubes. And it was able to perform functions such as counting up to 5,000 in 1 second. And the development of ENIAC actually paved way to the modern computer technology that we have today. And even a calculator now probably possesses more computing power than ENIAC did at the time, but it was a revolutionary step. But even with that limited, system machinery, Licklider actually understood its potential, and he predicted a future for human and computer symbiosis. So, like legendary von Neumann, Licklider saw similarities between the brain and the computer. They are both information processors with memory, and they have also complementary strengths. So he envisioned back in 1960s that an increasingly tight coupling of the two would emerge with unique capabilities. And today, computers are an integral part of our daily life. We already delegate a lot of important tasks to computers, even for our everyday daily lives, like remembering our friends' phone numbers and addresses and a lot of other things. And we can easily discount this idea as trivial now, but it was a radical thought at the time. And similarly, now, looking towards future, I can say it's not too far-fetched to imagine a future where human brain function is augmented with neurotechnology. And neurotechnology can continuously and daily help us perform our daily tasks. So I think the starting point is mobile neuroimaging, and we already have the beginnings of this. Like one important contribution and giant is Professor Michael Posner. He made a lot of contributions, but primarily the link between the brain activity and cognitive function. He helped understanding various cognitive processes, like high-level human tasks such as visual search, reading, number processing. And there is actually a test now called as Posner paradigm, but he used a lot of different neuroimaging technologies, very limited tools at the time, like even PET. But now we are seeing an emerging number of available technologies. So finally, I would like to then mention another pioneer, Professor Raja Parasuram's work actually led the neuroergonomics as a new scientific field. So Professor Parasuraman actually was a truly exceptional researcher, and he made significant contributions to a number of disciplines, human factors and cognitive neuroscience. And he touched actually to countless people's lives, including myself. And I'm lucky to work with him and learn from him. And he actually combined his interest into this new field, and his vision actually helped. So the technology wasn't available at the time. These are like 2000s, early 2000s. And what he envisioned was using neurotechnology, neuroimaging to capture information to help understand complex scenarios and tasks. Although the technology wasn't available at the time, he motivated and a lot of young researchers, very large number of people. And now actually he made it possible with the new technologies. Neuroergonomics now is a tool available, already demonstrated practical solutions to many domain-specific problems. So what he envisioned became a reality. So where do we go from here? And I think routine assessment of human brain is the next step. And we're already seeing the rise of wearables that can practically capture tools. Like imagine having a tool like that measures the brain function like the cardiac function. But I think we're already approaching that with wearables already contain and capture really large amounts of data about the human body and the physiological signals. But you may think that those extremely low-cost wearable sensors might not actually get anything useful. But actually, there are big initiatives. And one of that is NIH's All of Us program. And there was actually a recent study published in the Journal of Lancet Digital Health, and they reported real-time flu prediction may be possible using wearable heart rate and sleep tracking devices. And this was possible from data from Fitbit data from 200,000 people. So imagine what we could learn about the brain itself from such big data of millions of brains over days and months long. So sensor technology was one limitation, but we are seeing also a lot of improvements in those as well. So here is an example.
I wonder, Hasan, in light of our time and all, and you're really overloading our brains with all this different.
Yes, a lot of information. Yeah.
Now let me maybe ask us to, because we don't have much more time, and we really the whole interest here is, I know we've had some questions from people from other fields to see what all of this information about this new field and how you've developed it would trigger questions from colleagues here at Drexel and the ones that are dialing in, not so much about but what ideas it's creating for them. And I'd like to really start with Jennifer. I know Peter also has had his hands up, but Jennifer, since you're coming at this from a different perspective, let's maybe start with that. And then if we have time, we'll come back.
Well, one of the things I have to say is that I've been working with Hasan, or rather he's been guiding me on applying FNIR to the very practical question of what's going on in the brain during an eating episode. Because we know that MRI, functional MRI has given us a lot of information about interbrain brain section interaction. But unfortunately, when you're lying down inside of a metal tube, you can't eat. So I've been able with Hasan's magnificent assistance to actually get measurements of brain activity while people are sitting up, eating at a table with utensils and, all of the everyday accoutrements of life, checkered placemats and glasses and mood lighting and all that. And so I wanted to give that shout out to Hasan and also maybe ask him to mention a little bit about how functional testing, when it involves everyday movement, is a little bit different than testing cognitive function, because it took us a good couple of years to work that out, and he being an engineer and me not being an engineer, many times our conversations were more like this, and until we developed a vocabulary and an understanding of each other. But it's been a wonderful journey. Great job, Hasan.
Right. Thank you, Jennifer. Absolutely. The technologies are, all the neurotechnologies are fast growing and rapidly improving. And we are seeing many new innovations in the ways that we capture the brain and modulate the brain activity. There are so many things, we don't have enough time to even enumerate all the new emerging types of technologies. And we have actually one neurostimulation kind of work with Professor Levin on the line with a group of colleagues, that we are trying to develop a novel way of modulating the brain activity. But just this is really exciting, and that each of these new technologies actually have this tripling effect of opening up new kind of application areas. And when I say technology, it's not just the sensor, not just the electrode, but it's the whole continuum that enables an approach. That it can be the software, it can be the signal processing algorithm that enables better elimination of noise or motion artifacts that Jennifer mentioned. Like we have in my lab developed various types of motion artifact rejection algorithms that hundreds of labs are using now. It can be also statistical analysis approaches, how to kind of extract meaningful information from the signals, new types of machine learning approaches. In general, how to utilize and capture and utilize the brain signals and deploy it for a particular problem. So it's kind of the whole continuum. And that's the exciting part, and that's what we're working for, to develop new generations of these with and use them with a large group of colleagues and collaborators.
That's great. And I see Peter Lewin's hand is up as well, so maybe it's continuing the same thread here.
I think that there is not much I can add to it. I think that Jennifer and Hasan made a wonderful presentation. I just wanted to add that building bridges to all scientific fields, including law and all ethical issues, is fascinating. What comes to my mind, especially after the slide with the computer, is Commander Data from Star Trek Next Generation, but I'm not quite sure whether the younger generation knows what I'm referring to. So I think that this is a wonderful beginning of a long-term research, and I'm absolutely thrilled that it can be led from the School of Biomedical Engineering.
Mm-hmm.
I'm trying to see. I think we lost Robert. He's from our law school and was saying he had an interest in this topic. But this again shows the sort of value of trying to bring across things. If there isn't another one, I have a totally different question that your first part, which I thought was maybe what you were really going to talk about. That's why I started the opening questions there. Let me throw a slightly different question at you in this. So what you were talking about, and really what brought your to mind in terms of our approaching to invite to do this sort of mini scholarship, was you're creating a new field. You're creating a new discipline in a really highly interdisciplinary and competitive world of scholarship. And you gave us some insights into what it takes to do that in terms of the role of local and international collaborations, in terms of conferences, dedicated conferences, publications, citational analysis, which is what we recognized you for earlier in terms of how it raises attention to it. So my question is, from your work on this, do you have any sense of which kind of communication venue really is most effective or powerful for the ultimate reason for you doing research in an academic setting, and that's disseminating new information, new knowledge to broader communities, to stimulate other research, to enter into this whole research systematic query that, you know, you need to find out what others are doing, you're building on it. So with all these, and you clearly very strategically took steps, but where do you find you're getting the biggest bang for being able to disseminate your knowledge?
Yeah.
I'll add informal kind of events like this where you're trying to get to the layman to get it out. And yeah,
absolutely. That's an excellent question. I think first of all, I think the short answer is you need all of these communication channels to really expand and raise the awareness about this area, spread the word, and also share new developments. So it's both growing the community and spreading the ideas, new concepts, new tools that are developed, and making them available to the larger community so that they can actually build on those and develop even better tools. I think you need all of these communication mechanisms, conferences, symposiums, webinars, workshops, but also written forms of communication with the journals. They all have different roles. They all have, I think, complementary kind of contributions to the building up the community. So that's why we are, I think, trying to continue our efforts on all those, although it is taking a lot of time and effort to really put those together, and the community is working really hard to continue all these separate efforts. Are really worth it, and as we see the young generation, the students coming up with new ideas and translating that into new projects, and as we hear about those amazing projects, that's really stimulating. So that's encourages us to that there is actually a good outcome from all this, and we are seeing positive developments that the next generation will do great things as they use these tools. So that's, I think, the exciting part.
I'm sorry for folks already leaving, but you get?
Thank you, and thank you for your presentation. It was very informative too. I have more of a personal question. I see that you studied electric and electronics engineering during your undergraduate career. What were you motivated by to move from there, or not move, but combine this with neuro topics? Because I have like a similar intellectual curiosity. I'm studying computer science, and like I'm very curious about the process of thinking and how it works and how it could be broken down to be understood. So if you had any advice or simply explain yourself, I would very appreciate it and be happy by that.
Sure.
Thank you.
So yeah, that's very good. Actually, yes, as you mentioned, I have electrical and electronics engineering undergraduate degree, and I think electrical engineering, computer science are also very good to transition into biomedical engineering. So which is the study of the biological concepts and systems. So in an earlier life, I would say, like I have been doing a lot of work on computer vision and programming and device development, and a lot of these actually were focused on like different concepts, industrial projects maybe. But then I had a chance to do an internship focused on biomedical engineering, and I realized that I can take a lot of those tools and approaches and apply them to health problems, to understand the human function, and it can be different aspects, different systems, but applying to biology actually is extremely feasible. And of course, you need to learn more about the biological systems and that perspective to really make an impact. But it's the same tools and approaches can be applied. And at the end, you can actually make a difference in the quality of life of patients, or you can help with solving a health problem. I think that's extremely exciting to me. So that's why I kept on working in biomedical engineering. We can talk more if you have additional questions on this. I don't want to keep everyone here, but this is, I think, extremely good transition with that background.
So I would like to add, if I may, to emphasize the quality of life and to emphasize the fact that we engineers are not able to offer it without collaboration with lawyers and nurses and people who are involved with interaction with other humans, which means social services. So we have a space for everybody in biomedical engineering. And I think that certainly I'm beating my own drum, but I believe with my electrical engineering background, that biomedical engineering is the most universal and probably most effective engineering approach you can imagine needed.
This is all in the interesting area of how you build communities across siloed disciplines, and academics are traditionally known to have very narrowly defined fields. And so this is what's sort of exciting about your work and some of the areas, and as we're envisioning it, as we're seeing this, when we see what people are looking across different fields, and the whole role of getting information about it it's really interesting too. So, well, I see we're already losing a number of folks, and we're practically on time here. So let us thank Hasan very much for an overloaded brainy conversation, and really with a lot of very interesting things. So thank you so much, Hasan. And I think a few of us were happy to stay for a little after party. We always have some interesting comments that emerge there when others have leave. So I see someone else. So thank you very much, Hasan.
Thank you for the opportunity.
Absolutely. And thank you all for coming.